In this short video, I will introduce the concept of momentum, and I have here the definition of momentum, the relativistic factor gamma, the inertial mass m, and the velocity, which is a vector. Now, some important things to pay attention to. For the mass, we need to use the inertial mass. This is as opposed to the gravitational mass that we will use in calculating gravitational forces. Now, I will talk more about the gravitational mass when we work on the gravitational forces, but for now, just remember this m in momentum is the inertial mass. Gamma is it's a number. We call it the relativistic factor. This factor gamma is important when you have particles moving very fast, and in particular at speeds very close to the speed of light. And we use the letter c to denote the speed of light, and this is roughly 3 times 10 to the 8 meters per second. So if you have a particle moving, let's say 2 times 10 to the 8 meters per second with that speed, then you have to calculate the factor gamma. As far as having objects or particles moving at speeds much less than 10% of the speed of light. So let's say if you have objects moving at less than 10% of the speed of light, and by that I mean 3 times 10 to the 7 meters per second, then you don't need to calculate the factor gamma. If the object is moving very slow, then the factor gamma is roughly 1, and that means that the expression for momentum becomes momentum is approximately the mass times velocity. Okay. Now, I want to show you how you will do some simple calculations with this. Let's say that we have the velocity. We have the velocity vector. Let's make that to be velocity is let's say 1. The x component is 1. The y component is 2. And the z component is 3. Okay, so we have the velocity, and let's say we have a mass. I will make the mass to be 2 kilograms. Then I can calculate the momentum vector by taking the mass and multiplying it with each component of the velocity vector. So mass times velocity, in this case mass times the x component, 2 times 1 will give me 2, and then the mass times the y component will give me 4, and then the mass times the z component will give me 6. Now we don't have any special units for momentum, so I need to use the units of mass and then the units of velocity. So the momentum in this case is 2, 4, 6 kilograms meters per second, and that's how you do the calculations to find the momentum vector. I also want to point out some important properties of momentum. Because the mass is always going to be either 0 or a positive number, and in the vast majority of cases we're dealing with non-zero mass objects like a ball, a car, a person. The mass is going to be a positive number. Because this is a positive number, the momentum and the velocity vector will always point in the same direction. And what I mean with these two arrows pointing up, momentum and velocity are pointing in the same direction always. Now that means that momentum, if you have a velocity vector that points to the right, then I know that momentum will also point to the right. If you have a velocity vector that points up, I know that the momentum vector will also point up. That means that momentum and velocity cannot be anti-parallel, cannot be perpendicular to each other. They have to always point in the same direction. And finally, I want to point out one more thing. This is a vector equation, so this is true in the x, y, and z directions. Now, from this expression, I can also write that the magnitude of momentum is approximately equal the mass times the magnitude of velocity, which is the speed. Okay, so if I give you a mass of 2 and the speed of 2 meters per second, then the magnitude of momentum is going to be 4 meters per second. Now, let me write this. So if the mass is 2 kilograms and the speed is 2 meters per second, then the magnitude of momentum is 2 times 2, 4 kilograms meters per second. Now, I want to point out the difference. Here, I'm using the velocity, the vector, and that's why I'm getting the momentum to be a vector with the 3 components. Here, I'm only talking about the speed and the magnitude of momentum. So the speed is a number, like the number you see on a car. As you're driving, you see the speed of 65 miles an hour. You see a single number. It does not tell you the XYZ components. So this is a single number. You get a single number for the magnitude of momentum. If the speed increases, then the magnitude of momentum will also increase. If the speed decreases, then the magnitude of momentum will also decrease. So these were some important facts on a short introduction to momentum